All right, 3-4, we are talking today about perpendicular lines, and by the end of the video, you should be able to prove and apply theorems about perpendicular lines. So there's going to be 4 parts to the video. The first part, we're going to find distance, finding the shortest distance. Then we're going to solve problems using perpendicular lines, and then I'm going to talk about 3 awesome theorems, and then I'm going to give you 1 more problem. We'll do proofs tomorrow in class. Yay! Okay, so the first part, finding the shortest distance. Again, perpendicular lines, obviously, are lines that intersect at 90-degree angles. So this is the shortcut. If I wanted to write that 2 lines are perpendicular, I could say that AB is perpendicular to CD, and that would look like this, and CD. So that's perpendicular. Finding the shortest distance, it's the first thing we're going to do, and there's 2 pieces of vocabulary that you need to be familiar with. Perpendicular bisector is the first one. Perpendicular, again, we said meets at 90 degrees. When I say bisector, the word bisector means it's going to cut something in half. So these 2 pieces are going to be congruent. It doesn't mean anything about the line doing the cutting. So for example, I could draw something like this. The bisector is not necessarily being cut in half, right? This piece, top piece, doesn't look like this bottom piece. So if I wanted to say that AB was the perpendicular bisector, AB is perpendicular bisector of CD, that means that CD is the thing being cut in half, and AB is doing the cutting. So it's perpendicular bisector. And then the next thing that I want to discuss with you guys is when I talk about distance from a point to a line. In this picture over here, if I scroll down, if I wanted you to find the shortest distance from point A to line BC, so let me draw another one for you guys. Here's A over here, and here's CB over here. And I wanted to know what's the shortest distance from this point to this line. It's always, always, always going to be a perpendicular line. So if I extended it out, that is going to be the shortest distance. So I would write down that the perpendicular lines are always how you're going to find the distance, the shortest distance from one point to a line. So for the first part, name the shortest segment from A to BC. Again, that's going to be the perpendicular line, so that's, you could say, AP. But then the second part, it says write and solve an inequality for x. So again, we just said that this line is going to be shorter than this line or this line. So AP is shorter, less than all the other lines, AC or AB, because it's the perpendicular line. So from this point to this line, this is the shortest. There's nothing else shorter. So if I wanted to fill in what I know, well, I know AP is 12. And that's going to be less than AC. I don't know anything about AB, so I can't really use it. So less than x minus 8. Now to solve this, what you can do is you can add 8 to both sides, and now you have 20 is less than x. Unfortunately, this sounds funny in math, so what I really want you to do is say x has to be greater than. So flip this sign, x has to be greater than 20. So 20 is less than x is the same thing as x is greater than 20, but this is what I prefer. Okay, so that was the first question. I'm going to give you 1 more question. I want to see if you can answer it. So here's the second question. You can pause the video and try that on your notes. The second thing we're going to be doing is solving problems using perpendicular lines. So if I give you this problem and I tell you that this angle is congruent to this angle, I want you to solve for x and y, and can we conclude anything about lines L and M? Okay, well, if you think about it, these 2 angles are congruent to each other. So one thing you could do, one thing most people do, I should say, is they're going to be, oh, they're equal to each other? Cool. Then this angle must equal this angle. And then you get kind of stuck, right? Because you're like, well, wait a second, I have 2 variables. You know, what do I do now? Well, in class, we've talked about if you have 2 variables, you need to have 2 different equations in order to solve. So I need 2 equations. So let's look at this picture again and see what we can conclude. Well, these are a linear pair, right? So that means that they're going to add up to be 180 degrees. Well, if they're congruent to each other, then 180 divided by 2 is 90 degrees. So we know that both of these angles are now right angles. So I could say 11x plus 5y equals 90, and 4x plus 10y equals 90. And then we worked on this in class at some point this week. I can't remember. Then we're going to have to eliminate variables. Well, none of the variables, none of the coefficients are the same. So if I multiply this top one by -2, then I could eliminate the y's. So I'm going to do that over here. So let's see, 11 times -2 is -22x, 5 times -2 is -10y, and 90 times -2 is -180. And then same thing over here. Oh, sorry, I'm going to leave this bottom one the same. So 4x plus 10y equals 90, and then we're going to eliminate. So I'm going to add. These cancel out, and now I'm left with -17x equals -90, and then if I divide, 90 divided by 17, I get that x equals, no, that's y, -18. Nice try. 90 divided by 18. So I get x equals 5. Now that you have one of the answers, variables, you can plug it into any of these equations and solve for y. So I'm going to pick this equation because I think it looks nicer, but you can plug it into any of them. So this was our first step, and the second step would be to plug it in. Okay, so let's see, 4 times x plus 10y equals 90. This is 20, so subtract 20 from both sides, and I'm going to get 10y equals 70, and then y equals 7. So my answer is that x equals 5 and y equals 7, and we write that as an ordered pair, so 5, 7. This is how you write your answer. Oh wait, no, just kidding. We're not talking about systems. My bad. X equals 5 and y equals 7. That's your answer. Okay, and then the last part says, what can we conclude about the lines? Well, we said that they both are 90-degree angles, right? So if they meet at 90-degree angles, can I say that line L is perpendicular to line M? Yes, I can. So I'm going to write line L is perpendicular to M. And that kind of brings us to the 3 theorems that we're talking about in this chapter. The first theorem doesn't have a name. So again, I would write this on your yellow cheat sheet, pause the video. The first one doesn't have a nice name. You would have to write this on your proof. 2 intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. And you would draw this picture in your hypothesis and put this in your conclusion. And this is just what we did a problem on. If I tell you that we have a linear pair and these ones are congruent, then that means that these are going to be right angles because they're a linear pair, so it has to be congruent. Okay. The next one is perpendicular transversal theorem. This one does have a very nice name. So let's look at this picture and see if we can figure out what it's telling us. The hypothesis. We're given 2 parallel lines, so we have 2 parallel lines, and we know one line is perpendicular to the transversal. Okay, so this line is perpendicular transversal. Well, these are corresponding angles, right? So if this one is a right angle, wouldn't this one have to be a right angle? Yeah. If this one's a right angle as well, doesn't that mean that line P is perpendicular to line Q? Yes, and that's what our conclusion is. So if we have 2 parallel lines and we know one line is perpendicular to transversal, then our conclusion will be that the other line is also perpendicular to the transversal. That's what the perpendicular transversal theorem states. Okay, and the last one, if we have, looking at the picture, if we have 2 lines, I don't say anything about them being parallel, but I do say that both of these lines are perpendicular to a transversal, then that means that those lines have to be parallel. Because, well, one way would be because of the converse of corresponding angles, right? These are absolutely congruent. What you would have to write in a proof, and again, if you want to use converse of corresponding angles, that's fine. You can do that route. But this is another shortcut for the proof. 2 lines perpendicular to the same line, then those 2 lines are going to be parallel. Okay, so if we have this, then we can conclude that those lines are parallel. So this is the 5th way we can prove lines are parallel. Yay! Okay. We're running short on time, so really quickly, one last question. We're going to talk about this definitely in class. If I give you this picture, notice I didn't say anything about the lines being parallel. I didn't say anything necessarily about these lines being perpendicular, even though they might look like that. The only thing I really gave you was these angles, and I give you that these are both meet at right angles. If I tell you angle 3, sorry, I don't know how to do my angles. If I tell you just this picture, can we say that angle 3 is congruent to angle 5? Okay, well, angle 3 and angle 5, if these are both perpendicular to the same transversal, then that means that B and C have to be parallel. That's what the third, this theorem down here says. Okay, so these ones have to be parallel. So if they're parallel, angle 3 and angle 5 are alternate exterior angles. So yes, that is a valid conclusion. Angle 3 is congruent to angle 5. Let's see. If I give you just this information, can I say that angle 1 is congruent to angle 3? Well, I didn't say anything about line A. I didn't say it's parallel. I didn't give you any right angles. So even though it looks like it is, actually, no. These are not parallel. If they're not parallel, we can't use alternate interior angles. So I want to see if you guys can answer the rest of the questions. The fun fact of the video is, did you know 1 out of every 8 boxes of cereal sold in the United States is Cheerios? Yay! Okay, perpendicular lines. Nick, get excited. We're going to talk about perpendicular lines tomorrow in class. Yes!